Hey, so welcome back, and this is another daily code problem. So today it's called minimum average difference, and it's a medium level problem here. And so essentially you're just given this array, and you want to calculate this particular average difference with each iteration, but you actually want to get the minimum or the absolute difference, so you're really wrapping it in an absolute function to invert any negatives to positive. And so what this really means is just that each iteration, say you're at the middle here, is you take the sum on the left side and divide it by the number of values. So you take the average of the left side. And what that would be is 2 plus 5 plus 3, which is 10 divided by 3. And so that would be the average on the left side. And then you subtract it by the average on the right side, which is 17 divided by 3. And then you essentially just subtract them, and then you take the absolute value of it. But what you might see here is then, because of this, as we're iterating through this array from left to right, we're going to have to recalculate this average each time. And so that requires you summing the left-hand side and then dividing it by the number of values on the left-hand side. And so that means you have to kind of iterate each time on the left-hand side, which results in basically an n-squared algorithm. Because really, with each iteration, you're going to have to sum the left side and the right side, then you move your pointer over, then you sum the left side and the right side, move your pointer over. And so it's kind of like a 2 for loop way of doing it. But you can get around this by using something called prefix sum, which is essentially if you kind of convert this array to look something more like 2, and then 7, and then 10, where you're just keeping track of the running sum. And so you just do 2 currently, then you do, okay, there's 2, then you add 5 to it to get the next number, then you add 3 to 7 to get 10, and so forth. And just avoids you having to recalculate that running total each time to get the division. And so that can bring you down to like a O of n time complexity. And then what you do for the right-hand side is you take what's called the postfix, which is just the running sum from the left. So you just do 3 here, and then you have 3 plus 5 is 8, and then you do 8 plus 9 is 17, and so forth. And so that's how you can kind of look up what the average is in O of 1 time. But this would require extra space if we're actually using arrays, and so you can actually just avoid this and just keep track of what the current running sum is. You don't really have to store it in an array. And so that allows us to do this in like O of n time complexity and just constant space. So O of 1 space complexity. Okay, and so with that, let's go ahead and implement it. So first, let's just say, okay, what we want to do is just get the length of this array. And then we're going to want to actually get the sum of this array. And that's just going to represent like what our end side of the array is, so really the right-hand side. And so that with each iteration, we just subtract what the current running sum is from the total sum to then get those left sum and right sums. It might make more sense once I show you this in a second. So what we do is we get the right side, so let's just call it right, and then we just get the sum of this array here. And now we're just going to want to iterate through all the different values. And so we just say, okay, for I in the range of n, let's just keep iterating. And so we're going to want to return some index here because we're not really returning the minimum average difference, we're returning the particular index that has it. I can't really see where that shows you, but you want to return the index, okay? And so let's go ahead and define that. And so we're going to have the index, which is initially 0. And then let's set our current minimum to like infinity. And that we just say like minimum average or min, let's just say result. Just keep it simple. And that will be initially just infinity. Great. And so with that, what we're going to do is we want to calculate what the left-hand side is and the right-hand side. And so the left-hand side is just going to be whatever this particular value is added to the left-hand side. And so the left-hand side is initially 0. Great. And so we're just kind of incrementing it, so we're getting that running sum. And then with that, we want to get the right-hand side, which is essentially just decrementing the total sum. And that's the way you can just get the postfix on the fly without actually having to store it with any extra memory. You're just storing it in a variable of the postfix running sum. Okay, and so now we're going to want to calculate what the minimum average difference actually is. And so to do that, what we're going to do is we'll say like left average is equal to this, and then we have our right average. And so the left average is just going to be the left-hand side, and we want to round down since we're returning or we want to compare the integers. Or actually, I guess you don't technically have to since we're returning the index. And then we just do, okay, what is the current step that we're on? Well, we're currently on I plus 1. And so that's just because we're iterating through here with a 0 indexed array. And that just means that, okay, when we're considering the first value, we don't want to divide by 0. We want to divide by 1. And so you just add 1 here. So with that, then we're going to want to do the right-hand side, which is then just, okay, whatever the number of values that we have in our array subtracted by I, and then minus 1. And then this minus 1 just acts the same way as we want to exclude the current running number. Okay? And so from here, we're going to want to update this whenever we get our new result. And so we know what that is whenever we get the absolute difference of these averages less than our current result. And so this is what our current result is. And so if this is greater than the absolute differences of the difference of these two averages. So we have our left average and our right average. Great, and so if this is the case, then we're going to want to update this so that then, okay, our index is now this particular position. And let's also go ahead and update our result to this new minimum. Fantastic. I think that looks good. And so the only other edge case here is that in this scenario here, you might actually go out of bounds. And that's because, well, okay, what if what if n minus 1 is equal to I? And so that can actually just, because if you're at the end of the array, then I is going to be equal to n minus 1. And so you're going to actually be dividing by 0 here because we're iterating through to the very end. And so this is just an edge case that if you compile it once, you might see. So if we hit this point, then we're just going to want to say, okay, we only want to do this if n minus I is not equal to, or if n minus 1 does not equal to I. Otherwise, we just want to make sure that this is 0 and we're not dividing it by 0. Okay, and I think that makes sense. I don't see any other issues here. So let's go ahead and run this. Yep, looks good. And try submitting. Oh, looks like it didn't pass the section here. Let's check this. Let's add this to our test case. So we're returning 1 instead of 0 here. Okay, let's go ahead and run that. So let's see at every point what the current result is and the index I. Just get a bit more info. So we're saying 1 here because we're getting a 0 when we shouldn't be. So let's go ahead and maybe I was right and I just talking here. I need to round down and do an integer division. Oh, I plus 1 here. Oops, I didn't mean to delete that. Looks good. Probably should delete that print statement. Okay, yeah, great. So it doesn't look very good time complexity. Part of that is because I also threw in this print statement by accident. But yeah, that's today's algorithm. So essentially, once again, once you see that there's a lot of repeated work for finding out what the average is or really what the sum is, then you should go ahead and think, okay, how can I do a trade-off here and use some space to speed up our time complexity? And typically when you think of repeatedly getting the sum or figuring out what the average is, you should think of postfix or prefix. And if you can and you don't have to actually store it in an array, typically you should try to not use any extra memory and just compute this postfix and prefix on the fly. And yeah, that's pretty much it. So I hope it helped, and good luck with the rest of your algorithms. Thanks for watching.